Okay, so before we get to the integers modulo m, we have to talk about equivalence classes first. So suppose we're in a set with S that has an equivalence relation. So we could think, for example, in the back of our mind, we could think Z with congruence modulo m as that equivalence relation. Given an element A in S, the equivalence class of A is the subset of S, of S consisting of all elements equivalent to A. So we take, when we have an equivalence relation, we are going to take all, and we have a fixed element, we take all the other elements that are equivalent to it, and we put it in a set. So usually you'll write this as like an A bar, or you'll write it as an A. This is just notation for the equivalence class. Put it in blue or something. This is just notation. And then the actual set itself is a collection of all B's in S such that A is equivalent to B. So we collect all of the equivalent elements into one set, and actually S itself breaks down as a sort of a union of equivalence classes. We're not really going to need that, but I want to show you an example of these things. Let's actually keep this up here, and let's do two examples. We're going to consider Z with the idea of equivalence modulo 2. Okay, so what we're going to do here is let's look at the equivalence class of 0, which is either 0 bar or bracket 0. So what is this? It's the collection of all A's in Z such that 0 is equivalent mod 2 to A. All right, so let's unravel what that is. That's a collection of A's in Z such that 2 divides 0 minus A. So that's the collection of A's in Z such that 2 divides negative A. But if 2 divides negative A, that's the same as 2 dividing A. I picked an unfortunate order here. So that's the collection of A's and Z's such that 2 divides A. This is also known as a collection of evens. And if we were to write it out, all of the numbers that are divisible by 2, are here. And notice this is kind of half of Z, right? It's not, I mean, it doesn't make sense necessarily to say what half of an infinite set is, but it's kind of like half of Z. Let's look at what 4 bar is. So that's also written as brackets 4. Again, that's just notation. This is a collection of all A's and Z such that 4 is equivalent mod 2 to A. And that's a collection of all A's and Z such that 2 divides 4 minus A. And that's a collection of all A's and Z such that 4 minus A is 2k for some k. I'm going to be a little bit more explicit about divides here real quick. But divisibility satisfies the 2 out of 3 property. So 2 divides that one, and it divides that one. So therefore, it must divide the A, or at least the negative A. So really, this is just a collection of all A's and Z such that 2 divides A, which is the same as 0 bar. Okay. And of course, you can work out set theoretically, since 4 was already equivalent to 0, the equivalence class of 0 should be the same as the equivalence class of 4. Okay, so that's the equivalence class of 2 even integers, and they're the same thing. And if we took any other even integer, we would get the same answer. Let's now look at an odd. So let's look at 1 bar, which we could write as 1 bar, or we could write it as brackets 1. Again, it's just notation. It means the same thing. So that's a collection of all A's and Z such that 2 well, let's write it out explicitly. 1 is congruent mod 2 to A, which is the collection of all A's and Z such that 2 divides 1 minus A, which is the collection of all A's and Z if we wanted to be a little bit more explicit. 1 minus A is 2K, sum K in Z. And we could, if we like solve here, solve A's and Z such that A, let's see, we move the A over and we subtract the 2. So it's 2 times negative K if we like, plus 1. Now, if you think about that, this is just exactly the collection of all odd numbers. So this is like -5, -3, -1, 1, 3, 5, and so on. And just like in the example with evens, this is going to be the same as 3 bar. It's going to be the same as -5 bar. It's going to be the same as, let's put equals here. It's going to be the same as whatever your favorite odd number is bar. They're all the same equivalence class. And this is sort of the other portion of the integers. This is the other half. And together, 0 bar and 1 bar are all of the integers. So this is a quick introduction to equivalence classes, and we'll dive a little bit more deeper into them for Z with congruence modulo M in the next video.